I'm going to take you through the process of switching this quadratic, and we're going to do 3 of them, a quadratic from standard form to vertex form. The reason that we do that is that standard form is not really that useful for what we want. When I look at the function in standard form, I know that it opens up, I know that it's fairly narrow, I know that it has a y-intercept of 20, but I don't know where the vertex is, and the vertex is kind of that key point that defines the parabola. So I want to be able to put it in vertex form so I know that. The steps are written out there, and I'm just going to go through those steps. The first step says, factor out the coefficient of the first term from the first 2 terms. So for that, the first term is the 3x squared. The coefficient is 3. We want to factor 3 out, but just out of here, take out a 3. So we're not taking out the greatest common factor, which is usually what you do when you're factoring. We're just taking out whatever that coefficient happens to be. So this is going to look like y equals 3. And then x squared plus 6x. And I'm actually going to leave a big space and then put the plus 20. And I'm leaving the space so I can do the next step. But this is still equal, right? Because if I were to expand it, that's 3x squared plus 18x, and then the plus 20 at the end. That's the first step. If there's a coefficient there, factor it out. Sometimes it's just an x squared. You don't need to do that first step. But here we do. And then it says complete the square to make a perfect square trinomial. That's what we were doing earlier. Over here in the last part of that, we were figuring out what's that number that has to go on the end that will make it a perfect square trinomial. And if you remember, we said you take half of the middle term and square it. So half of 6 is 3. 3 squared is 9. That's the number that I'm going to put in there. I'm going to go plus 9. Half of 6 is 3. 3 squared is 9. I put a plus 9. Now this is a perfect square trinomial. X squared plus 6x plus 9. The problem is I can't just randomly add 9 to an equation, right? When I do that, now it's something different. So I have to make it the same again. And that's why it says in the instruction, by adding a 0 pair. If I add 9 out of the blue, well, that's not okay, so I'm going to subtract 9. That's what it means by adding a 0 pair. It's not okay to just randomly add 9. It completely changes the equation. But if I also subtract 9, then really what did I add? 0. And it's okay to just add 0, right? The goal here is not to change the value of the equation. We're just changing the way that it looks. The third step says remove the extra term from the brackets. Well, what's the extra term? The negative 9. I don't want that, right? I just had to put it in there to keep it equal, but I don't actually want it. So I'm going to get rid of that, take it out. All I'm leaving in here is the perfect square trinomial, x squared plus 6x plus 9. I want to take the negative 9 out, but when I take it out, it's not a negative 9 anymore. Anybody know what it is? Still negative. It's a negative 27. Why is it a negative 27? Right. You have to multiply it by 3. When it's inside, it's multiplied by 3. Right? If I want to take it out, I actually have to multiply that. So 3 times negative 9 is negative 27. The last step is to factor the trinomial and simplify. So, and remember we also did that. How do we factor that perfect square trinomial? Take the square root of the first term, x. The sign of the second term, it's a plus. And then the square root of the last term, which makes it a 3, and then squared. And the reason that we can always factor it using that shortcut is we always picked the right number to make that work. And then I have to do negative 27 plus 20, which is negative 7. And there's the equation in vertex form. Now I know a little bit more about it. Now I know what the vertex is. It's -3, -7. What you should be able to do now to check is graph the original equation, y equals 3x squared plus 18x plus 20, and graph the new one, y equals 3 times x plus 3 squared minus 7, and what should you notice? They're the same graph. Here's the next one. Algebraically determine the coordinates of the vertex of this. So it's not actually asking us to switch it to vertex form, but if we want to algebraically find the vertex, then this is one way to do it. So we're going to complete the square so that we can tell where the vertex is. Do you remember what that first step was? Yep. Factor out the coefficient just from these two terms, right? So I'll take out the -10, and then I'm left with x squared minus 4. Because I take 40 divided by -10, I get -4. And then I'm going to leave that big space so that I can complete the square, because that's the second step. The second step, oh, I made a mistake. Does anybody see it? I forgot the x, yeah. It's not a 4, it's a 4x. Now I can complete that square. I need to figure out what number goes on the end there that will make it a perfect square trinomial.
Plus 4.
Right, plus 4. So I'll go plus 4. But if I add 4,
Take away 4.
I have to take away 4. That 0 pair. Don't forget the subtracting part. Add 4 and subtract 4, because now the first 3 terms inside the brackets are a perfect square trinomial, which is what we want so that we can factor it into vertex form, which has x minus p squared. So then the next step, is to take that extra term out. So this is -10, and then we'll have x squared minus 4x plus 4. That's the part that we want in there. Take out the -4.
40.
It's going to be positive 40, right?
Let's do.
Because it's -4 multiplied by -10. You have to do that multiplying when you take it out. -4 times -10. And that's why it becomes that 40, positive 40. So then we're just going to factor and simplify. And it's easy to factor because we know it's a perfect square trinomial because we built it. We made it so that it was a perfect square trinomial. So when you factor it, x minus 2 squared plus 42. Square root of the first term, square root of the x squared is x, sine from the second, square root of the last. That's where the x minus 2 comes from. Don't forget that squared. And then plus 42. It's actually asking us what are the coordinates of the vertex? What are the coordinates of the vertex of this one? 2 and 42. Remember, take the opposite sign. Here's the last one that I want to do. Switch from standard to vertex form. So, same as what we've been doing. The first step is factor out the coefficient from the first 2 terms. Well, this one actually only has 2 terms, but this one's a little bit trickier because we're going to take that 5 out. That becomes an x squared, but what does the -3x turn into when you take out a 5? Yeah, 3 over 5x. And there's nothing there at the end, but we do need to complete the square. Oh, this is kind of tricky, isn't it?
3 and a half is 3 over 5.
But the process is still the same. Do you remember what you do with that number once you have it? Take half of it and then square it. So we'll take half of 3 over 5, and that's 3 over 10, and then we'll square it. Square that, and that's 9 over 100. So that's the number that we add and subtract. This number, the 9 over 100, comes from over here. Take half of the 3 over 5, gives you 3 over 10. Square it is 9 over 100. So I'm gonna take out the negative 9 over 100, but I have to multiply it by 5. 9 over 100 times 5. Right, I have to multiply it by 5. So 5 over 1, which is 45 over 100, or if you reduce it, 9 over 20. So minus 9 over 20. The good thing is we don't have to go through decomposition to factor this thing, because that would be a mess. We just factor it using the shortcut for perfect square trinomials. So it becomes y equals 5, and then x, it's negative because the middle term is negative, and then the square root of 9 over 100. Square root of 9 is 3, square root of 100 is 10. So it's 5 times x minus 3 over 10 squared minus 9 over 20.